So on today's video, we're going to discuss what to do with zero exponents and negative exponents. And in order to do that, I'm going to make a little pattern here for you. This is 3 to the 4th power, 3 to the 3rd, 3 squared, 3 to the 1st, 3 to the 0. So if you notice the pattern, the bases are staying the same, but the exponents are dropping down by 1. So the pattern on the exponents is subtracting 1 each time. You're going from an exponent of 4 to 3 to 2 to 1, 0, and then continuing on, -1, -2, and so forth. But the bases are staying the same. So if you go do the math, 3 to the 4th is 81. 3 to the 3rd is 27. 3 squared is 9. 3 to the 1st is 3. So if you follow this pattern over here, what is happening is you're dividing by 3. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 containing the pattern means this is 1. So 3 to the 0 power is 1. A lot of people see this and immediately think, oh, it's going to be 0. It's not going to be 0. It will be 1. And now to the negative 1. So the 0 going down by 1, so 3 to the negative 1. But if we follow the same pattern over here, we're dividing by 3. 1 divided by 3 is simply the fraction 1/3. We're taking 1 and dividing by 3. If I take this number and divide by 3 again, guess what that is? It is now 1/9. If I take 1/9 and divide by 3, I get 1 over 27. So 3 to the negative 1 is 1/3. 3 squared is 1/9. 3 to the negative 3 is 1 over 27. This comes in handy because there's a rule that says anything to the 0 power is always 1. So if I had the number 5 to the 0 power and put it in the calculator, it's going to tell me it's 1. If I take 83 and raise it to the 0 power, it's 1. If I take 2,348 and raise it to the 0 power, it's 1. If I take a negative number, put it inside parentheses, and raise it to the 0 power, it's also 1. So anything raised to the 0 power is 1. Now, negative numbers. We never like to leave negative exponents. Not the base number. The base number can be negative, but the exponent cannot be left as a negative. So what we do to get rid of it, and there's a little rule that's on your formula chart that tells you this, but we already know by following the pattern it's 1/3, but we don't want to have to follow a pattern every time to get to this. What you do is this is a whole number 3 to the negative 1. So this is a whole number, which means I can make it into a fraction by putting it over 1. If I take this piece, this base and its exponent, and move it to the other side of the fraction line, the exponent becomes positive. So if I take this thing and move it down to the bottom, I now have 1 over 3 to the 1st power, but now the 1 is a positive 1. And 3 to the 1st power is just 3, so this equals 1/3. And is that what I told you it was following the pattern? Yes, it's 1/3. If I do the same thing here, 3 to the negative 2, I'm going to take this that's now on top and move it to the bottom to make the exponent positive. So that gives me 1 over 3 to a positive 2. I just took it from the top and moved it to the bottom. There was nothing left on top, so I leave a 1 up there. Now this is 3 squared, and what is 3 squared? It is 9. So that's just the pattern to kind of show you how the 0 and negative exponents affect, but this is the shortcut version on it. Now, on your reference sheet on STAR test, they will give you the formula or the rule for the negative exponents, which is if I have a negative exponent, I can pretend this is a fraction, and all I got to do is move it to the bottom, and now it becomes positive. Now, if the negative exponent was already in the bottom, all I have to do is move it to the top, and it becomes positive. So crossing the fraction line changes the sign of the exponent. But this is on your reference sheet to remind you if you have a negative exponent, you want to get rid of it, and all you got to do is move that piece to the bottom, and now it becomes a positive exponent. Now, the 0 rule is not on your reference sheet. That one you just have to know, or just try plugging some numbers in to raise them to the 0 power and see what happens. But any number raised to the 0 power is 1, and of course the base number cannot be 0, otherwise it's undefined. But as long as it's anything, as long as the a is anything except 0, you can anything raised to the 0 power be 1. And I don't think they're going to ask you about the 0 as the base. So pretty much anytime you have 0 as the exponent, it's going to equal 1. Okay, so let's go do some examples. Simplify each expression. You never want to leave anything with a 0 exponent. You don't want to leave anything with a negative exponent. But since they want us to simplify this, 3 to the 3rd power, just put it in the calculator, see what the math is. You can either do 3 times 3 times 3 at enter, or you can do 3 rooftop 3. Remember that rooftop key is right below the equal sign. It looks like a little rooftop. 3 to the 3rd power is 27. So hopefully you can put that in the calculator and get the answer to that. 3 squared is 3 times 3. So either put 3 times 3 in the calculator or put 3 squared in the calculator, and it will tell you it is 9. 3 to the 1st power, that means I just have a single 3. That is just plain old 3. There's always a little exponent for every number. We just don't write it. So that is just 3. 3 to the 0 power, what did we say anything to the 0 power is? That equals 1. 3 to a negative 1. Remember, right now, it's on top of the fraction line. So to make this exponent become positive, I need to move it to the bottom. So now I don't have anything on top, so I leave a 1 on top, move the 3 to the bottom, and now it is a positive 1. So this is just simply 1/3. 3 to the negative 2, right now it's on top, so I'm going to move it to the bottom. So now I have 1/3 squared, which equals 1/9, because 3 squared is 9. 3 to the negative 3, right now it's on top, so move it to the bottom. And now, since there's nothing on top, I need a 1 up there to hold this position. But on bottom, I have 3 to the positive 3. Go ahead and do the math because it's all numbers. 3 to the third power is 27, so this is just 1/27. All right, so those are just simplifying when they're all numbers. Okay, next one. Simplify expression, and again, leave them as fractions if we need to. This is no negative exponent, so I don't need to move anything. It's going to stay on the bottom, so 3 to the third power is 1/27. No negative exponents, so they stay where they are. 1 stays on top, 3 squared stays on bottom, and 3 squared is 9, so 1/9. 3 to the first power, again positive, so it stays where it is. It's going to stay on bottom, so 1/3. 3 to the 0 power, that piece there, I do not want it to be left as a 0, so 3 to the 0 power is 1, so this is 1/1, which is just simply plain old 1. Now this has a negative exponent. We don't want to leave it as a negative exponent, so I'm going to move it to the top. So that means now on top I have 3 to the first power. Now you may say, well, there's a 1 up there. Well, it's 1 times 3, and 1 times 3 is still 3. So this 1 just means I just have a single 3. So this is just simply 3 on top. 3 to the 1 went up on top. There's nothing else up there except times 1, so it just stays as a plain old 3. 3 to the negative 2, again, I don't want a negative exponent, so I move it across the fraction line. It's going to become positive. So this is 3 squared now on top, and just a 1 on bottom, so you don't have to put the over 1 on bottom. And 3 squared is equal to 9. 3 to the negative 3, I don't want a negative exponent. Again, move it to the top. So 3 to the third is now on top. I don't have to put the over 1 because that's just irrelevant. You can put the over 1, but you don't have to. So 3 to the third power is 27. All right, 3 times 3 times 3 is 27. So now we get to the more interesting ones. Remember, you can make this into a fraction, right? So as soon as you look at this, you see these negative exponents. Now this negative exponent only goes with the x. It has nothing to do with the 2. The 2 has its own little positive 1 exponent. Remember I said everything has a little exponent. So that 2 has a positive exponent. It is going to stay on top. I want it to have a positive exponent. But this x to the negative 1 is a negative exponent, so let's move it to the bottom, and now it's a positive 1. Y to the negative 2, I don't want a negative exponent, so let's move it to the bottom. It's now y to the positive 2. So I have everything's with positive exponents. I only have a single x piece, a single y piece. I am done. Number 2, remember all these are over 1. So the 3 to the first power is fine where it is. I'm going to leave it on top, so 3 stays on top. The x negative 2 needs to come to the bottom to make it a positive exponent. The z is fine where it is because it already has a positive exponent. I want them to stay positive. So when I'm done, it's 3z squared over x squared. Number 4. At any point you want to stop and go work these and then come check your answers, feel free to do that. 3 to the first power already has a positive exponent, so it's going to stay on top. So 3 stays there. X squared, yes, it stays where it is. It's already positive. Now, the y to the negative 3 needs to go to the bottom. So this is y to a positive 3. Don't forget to make it positive when you move it down. And the z needs to move up to the top, so it's now positive. So this is z squared with a positive 2. So when you're done, you should have all positive exponents and only a single x piece, a single z piece, and a single y piece. 8 over 4. Now, these plain numbers out front, these are just plain old big old numbers, 8 divided by 4. If you put 8 divided by 4 in the calculator, those are your coefficients, it reduces down to just a whole number 2. So I have 2 on top. X to the 0 is a 1, so this is times, because this is 8 times the x, and x to the 0 is a 1. And then y squared is still going to stay on top. This 8 divided by 4 gave me the 2, so the 4 is gone. Z to the negative 1, I don't want it to be a negative exponent, so I'm going to move it to the top. So there's nothing left on bottom, so I can ignore the bottom. But 2 times 1 is just 2, so since that became a 1, it basically goes away because I'm multiplying, and 1 times anything stays whatever the numbers were. So this is just a plain old 2. Y squared Z to the 1 is your final answer, and it is all on top, so you don't have to put over 1. Just remember that x to the 0 power became the 1. That's why times 1 didn't change anything. Okay, so now this one over here. 3x to the negative 2. So I see zeros and I see negative numbers, and so we know we're going to move things around. This 3 has a positive exponent, so leave it where it is. It is staying on top. X to the negative 2 goes to the bottom now, so it's a positive 2. The y3 is a positive, so it stays where it is. Z to the 0 means that's times 1, and do I have to write times 1 because it really doesn't change anything, right? So that piece just goes away because it's times 1. 4, x squared z to the negative 4. We're just simplifying this down. We do not want to have negative exponents, and we don't want to have any 0 exponents. So the 4 already has a positive exponent, so it stays where it is. The x squared is positive, it stays where it is. But z to the negative 4 needs to go to the bottom, and now it's z to the positive 4. That's all we're doing is rewriting these in simplified form, and it's improper to have a negative exponent, and it's improper to have 0 exponents. So this x to the 0 means I have a positive 1 times whatever the rest of this is. Now, y1 needs to go down to the bottom, and z can stay where it is because it's already positive. So I just have a 1 over y to the first z squared. This one, negative exponent needs to come down, the negative exponent needs to come up. So on my final one, x squared stays where it is, the y goes to the bottom, and the z comes to the top. And there you go. That's all we're doing. It's just knowing how to use the laws of exponents to simplify these. So rewrite, get rid of the negative exponents. 2 is just staying on top because it's got a positive 1 exponent. The x goes to the bottom. The y and the z stay where they are because they have positive exponents. There's a little positive 1, little positive 1, little positive 1. So just remember there's little exponents here, even though you don't see them. And if you want to draw them in so you can see them, that might help you not make a mistake. 2 stays on top because it has a positive exponent. The x has a positive exponent. It stays where it is. So the 2 and the x stay on top. The y also has a positive exponent. It stays on top. Oops, that's a 3. And the z needs to go to the bottom, and now it's a positive 3 exponent. So z to the 3rd power. 3 over 6, that's the big numbers out front, coefficients. 3 divided by 6, if you put that in the calculator, it will tell you it's 1/2. So if I reduce that fraction down, it's just plain old 1/2, 1 on top, 2 on bottom. Y squared needs to stay where it is. It already has a positive exponent. The z needs to come to the bottom. This was a 2. Let me make this a better 2. Z came to the bottom, and now it has a 3 exponent. The x needs to go to the top, and now it's squared. So I have y squared on top, x squared on top, 2z to the 3rd on bottom. Last one. Again, the coefficients out front, the big numbers, 9 divided by 3. If you put that in the calculator, it will tell you it is a whole number 3. So 3 is now left on top. The z squared can stay on top because it's positive exponent. The x squared can stay on bottom because it is a positive exponent. Y to the negative 3 needs to go to the top, which makes it now a positive exponent. And now you're an expert at simplifying negative exponents and 0 exponents.